Hey friends, welcome back to Tuesday's version of January Number Corner. I know that we're still probably getting back into the swing of things after being off for 2 weeks, but we're back and that means that we have things to do and you guys are responsible for your learning. I do believe this month there is a Number Corner checkup that will count as a grade. So make sure that you are making the effort to participate, to pay attention, and to really think about the mathematics that we're doing throughout the different workouts that we're doing this month. I do want to correct something with you guys though. I believe in yesterday's video, I talked about how we were going to collect 3/4 a day starting from January 1st. Really, I believe it's 3/4 a day for the days that we're in school. So we're actually ahead on our collection. And so we're not going to update that today, okay? And if I hear anything different between today and tomorrow, then I will make sure to update it respectfully, okay? So today is January 5th. It is Tuesday, and we have one thing and one thing only to do today, which is one of my favorite things to do, and I know it does take a lot of time, but it's okay. And it's a problem string. And today's problem string is focused on multiplication and division strategies. I want to remind you, as you're getting out your Number Corner workbook and flipping to the next available page in the back of your journal, go ahead and label it problem string 13. But I want to remind you that when we do a problem string, we always start off with easier problems. And those problems somehow will connect to the problems that we will then encounter as we continue the problem string. So when you see this first problem, you may think, oh, this is very easy. But I want you to expand your thinking in terms of representation. Representation matters. We are going to use number line to represent our thinking, even if we just know the answer just like that, especially if you guys have been playing Splat or some of the other games that we've played for Number Corner since the beginning of the school year, okay? So, are you ready? Let's jump in. I know that was kind of a long intro, but that's okay. We're going to move through this as quickly as possible. So, here is the very first problem for today's problem string. And I will zoom in. It says 10 times 9. We know 10 times 9, right? What is 10 times 9? Right. But because I told you it's going to connect to what we're doing later, we're going to go ahead and draw it out on a number line so that we can represent our thinking. So pause this video very quickly. Go ahead and make your number line starting at 0, and it says make 10 jumps of 9 to figure out where we're going to land. Go ahead, do it right now. Okay, so hopefully you have your number line drawn. Here is mine. It said start at 0 and make 10 jumps of 9. Where do we land? We know it's 90 because when we're multiplying, we're taking a number and we're iterating it. That's a fancy word for saying we're copying it over and over and over. So if we have the problem 10 times 9, then essentially we're taking 9 and we're copying it 10 times, or we could do 10 and copy it 9 times, okay? So let's look at the second problem. And that is 90 divided by 9. 90 divided by 9. Do you guys see the relationship with this problem and the first problem? If not, it says how many jumps of 9 does it take to get from 0 to 90? And we just did that. We went from 0, we landed at 90 because we were doing 10 times 9. We did 10 nines. Now it's asking how many jumps of 9 is it going to take to get to 90? It's the exact same thing. We count our jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is 10. So I can go ahead and fill that in. The answer is 10 here, and the answer is 90 here. And we've used the same representation. So boys and girls, when you see a question that says explain or show your thinking, a number line is the perfect way to go, okay? Let's go ahead and look at the third problem. 90 divided by 10. How many jumps of 10 does it take to get from 0 to 90? Can we use this same model? No, we can't use the same model because we've jumped 9s. We have 9 iterated over and over. And now we want 10. We need how many jumps of 10 does it take to get from 0 to 90? So here's my 0, I know. Here's my 90, I know. Let's count by 10s really quickly. And oh, that's a funky looking 0. We know how to count by 10s, right? All right, let's do it. 0, 10, 20, 30. Woo, that was funky 30. 40, 50, 60, 70, 80. Yikes, Miss Trammell was not proportionate. So I am going to actually do this again, and I'm going to try to be less sloppy with it. So just give me one moment. Okay, I tried to fix my jumps. I don't know if they look that much better, but you guys get the picture, right? So how many jumps of 10 did we just make? Here's 1 10, 2, 3, 4, 5, 6, 7, 8, 9. We jumped 10 9 times. So we see that the distance is the same, 0 to 90, but the size of our jumps and the number of jumps are different. I tried really hard to represent that with my picture here. It's kind of hard using the computer and not having a wireless mouse. So let's go ahead and move on to the next problem. 3 times 30. Maybe you guys already know 3 times 30, but we're going to represent our thinking on a number line. We start at 0 and make 3 jumps of 30. Where are we going to land? Work it out really quickly. All right, some of you may be done. You have 3 jumps of 30. Where are you landing? By gosh, did we land back at 90? We sure did, but our number of jumps and the size of the jumps are different still, right? Right, let's look at the next problem. That was easy. How many jumps of 30 does it take to get from 0 to 90? Yeah, we can use the same number line. We made how many jumps of 30? We made 3 jumps of 30 to get from 0 to 90. Hopefully you're seeing the connection between the multiplication problem and the division problem. Let's look at the next one. 90 divided by 3. Whoa, that's a big difference, right? So instead of having jumps of 30, we're now going to have jumps of 3. And it's going to be a lot of jumps. So Miss Trammell is going to make her very best effort to show jumps of 3 all the way to 90. I'm going to pause my video to do so, and I want you to try to do it while I'm doing it, okay? All right, go for it. Good luck. Okay, did you do it? I made my very best attempt, and each one of these jumps are worth 3. Now, in a perfect world, they'd look all proportional because they're all the same amount. You know, we're jumping 3 each time, but Miss Trammell is not perfect, so that's why they don't necessarily look the same size. But how many jumps of 3 did you make? We would have made 30 jumps of 3. We know that 3 times 10 would be 30, so in each of these 30 jumps would be 10 jumps of 3, essentially. So again, the size of the jump changed, right? What else changed? What else did we talk about? Right. The size of the jumps changed, but the distance remained the same. What else changed? The number of jumps that we had to make. So what's the big idea here? Big idea is that multiplication and division are inverse relationships. Say it with me. Inverse relationships. That means if you know 10 times 9 or 9 times 10, You know 90 divided by 9. If you know 3 times 30, you know 90 divided by 30, or even 90 divided by 3. Remember all those years we talked about fact families with addition, subtraction, and then eventually possibly multiplication and division? Now it's coming in handy, right? It's just that with division, would you want to make a smaller number of larger jumps or a greater number of smaller jumps? Right, it's so much easier to make a smaller number of the larger jumps. For example, it was easier for Miss Trammell to do 3 jumps of 30 than it was for me to do 30 jumps of 3. All right, let's keep working. Let's see what else we have for this problem string. 6 times 15, work it out. Start at 0, you're going to make 6 jumps of 15. Remember we talked about it's easier to make the larger jumps a smaller amount of times than the small jumps a larger amount of times. Okay, so 6 jumps of 15, go. I hope you worked it out. Here's what I've done. Where do you land when you make 6 jumps of 15? Yeah, you land at 90. It seems like 90 is our number for today, right? We found another factor pair for 90, 6 and 15. Let's look at the next problem. Let's see if it relates. 90 divided by 6. What do you know? Yes, we can use the same number line. It says, how many jumps of 6 is it going to take to get from 0 to 90? Oh, can we use the same number line? Miss Trammell was on a roll and she didn't even pay attention. Shame on me. Right, we have to make 6 equal jumps to get from 0 to 90. And they want to know how big is each jump. Well, we know that, right? If we take 6 equal jumps to get from 0 to 90, then that's 15, right? We had to make jumps of 15. But if we have to make jumps of 6, how many jumps do you think we're going to make? Thinking about those fact families, we probably are going to have to make 15 jumps of 6, which is nowhere near as fun to do as hopping by the bigger chunk. Remember, that was one of our big ideas? Okay, so we hop by 6, we'd have to do it 15 times. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We'd still land at 90, but we just made smaller jumps and more of them. So our answer here would be 15. These numbers are still in that fact family. Let's look at the next problem. 90 divided by 15. How many jumps of 15? Yeah, we've already done that. We made 6 jumps of 15. So this time they tried to trick me. They did it backwards. Shame on Bridges. Okay, we have 2 more to do, guys. 2 more, we can do it. Yeggers. 92 divided by 30. Okay, I'm going to scroll up. And I believe, did we do 90 divided by 30 earlier? We did. 90 divided by 30 was 3, but now we have 92. So watch what's going to happen. I'm going to change my color to red here. And we'd have to go 1, 2, and that would be my 92. What does that tell you? What would 92 divided by 30 be? It says how many jumps of 30 would it take to get from 0 to 92? Or I could do my 92 on this number line. Since we jumped by 30 here, we still would make 3 jumps, right? But then we'd have to make 2 extra jumps to get to 92. That's where that remainder comes in, right? So I guess our question is how are we going to record that? We know that 92, well, I'll say 90 divided by 30 is 3, right? So 92 divided by 30, we're still going to have 3, but we have 2 more jumps to make, or a jump of 2 to make. So I could write that as 3 remainder 2, or I could write it as a fraction. You know how we've been talking about fractions a lot lately this month? If you haven't gotten the hint yet from our 3/4 a day. So I could write it as a fraction. We only jumped 2 more out of the necessary jump of 30. So it would be 2/30, right? Or I could simplify that and I could say 2 is the same as 1/15, because I'd have to make 15 jumps of 2 to get to what? 30. 15 times 2 is 30. So it'll be 2, 2, 2, 2, 2, 2, 15 times. So that's how I would notate that. 3 and 1/15. Okay? Okay, so now we have the very last one. I wonder if it's going to be another tricky one. Let's see. Yikes. It is. It says 92 divided by 6. Well, we did 90 divided by 6 earlier. Remember? It was our 90 divided by 6. We had equal jumps of 15. But this time we have 92 divided by 6. So I'm going to get my same red pen here, as if I'm jumping right to 92. So 92 divided by 6, we know is 15, because we could say 92 divided into 6 equal jumps would be 15. Or I could say 92 divided, you want to jump by 6 until you get to 92. Then you would have still 15 jumps here, or you jumped by 15. So you can think about it both ways. But now I have this remainder of 2 left over here. Still have a remainder of 2. How could we write that as a fraction? Because this was our 6. Yeah, it's 2 out of the 6, right? 2, 6. So this actually might be the best number line to represent our thinking. Since we went 2 more out of, but we needed to go another 6 in order to make it an equal group, because division is all about equal groups, equal sizes. So I could write that is 15, but I still have 2 left over, so it will be 2 6. Or I could write the equivalent fraction of 2 6, just to simplify it a little bit, as 1/3. It would take 3 of those 2's put together to make a full jump of 6. Does that make sense? We're going to keep working on it. So today we have done multiplication and division. We know that multiplication and division are inverse operations. They're related to each other. If you know one operation, if you know multiplication, then you can figure out the division. If you know the division, you can figure out the multiplication. But we also stress the importance of representation using a number line. So you can use a number line. So for 90 divided by 6, we could think about that as, I want 6 equal jumps. How many jumps should I make? Which might be a little harder. Or you could say, okay, I'm going to make jumps of 6 until I get to 90, which may be easier, because then you don't have to think, what's an even amount of jumps that I can make 6 times? Okay, so tomorrow we'll be back again for Number Corner, and we'll be doing a whole new activity to introduce our month of January. I hope you guys had a great Tuesday. I'll see you tomorrow. Bye-bye.